Hello, I'm Sam, aka 44,100 Hz, and this is part 1 of my programming tutorial on how to write an FM synth in Rust and SDL2. Today I'm going to produce a simple sine wave. Let me explain sound waves in a simple way. I'm assuming that you know a little bit about sound, but I'm just going to go over some concepts. This is how an analog sound wave works. Let's say that the wave being in a higher position indicates that the speaker is moving outward, and a wave in a lower position indicates that it's moving inward. This is how an analog tone would be represented, say in a physical media. But for a digital wave, we can't really do that. Instead, we have to take a series of samples. When we synthesize a tone, all we do is provide a series of points. Now, in this demonstration, we're going to be using floating point numbers, and these numbers range from 1.0 at the top of the wave to minus 1.0 at the bottom of the wave. So, in order to give a sine wave, all we have to do is take the points on the sine function in order, like so. The way we do this is by keeping track of something called the phase of the wave. Imagine that we have a little cursor position on the wave, and that cursor is moving forwards at a constant rate. Wherever that cursor is, that's the sample that we send. So it may start at this sample on the wave, and then this one, and then this one, and then this one. So we would take the sine of an increasing number and use that result as the input for our audio mix in order to have an audible sine wave. The rate at which this phase increases is called the pitch. In our case, with a sine function, we want the function to loop 440 times per second, or 440 Hz, in order to produce the middle A note that's frequently used for tuning. In order to do this, we have to have the wave repeat 440 times per second, meaning that we would increase the wave at a rate of 2 pi times 440 divided by the sampling frequency of the wave. In order to understand how to write code for Rust SDL2, first we have to understand the API. So let's take a look at how they generate a wave. I'm going to use the audio square wave example from their GitHub repository. So first, let's examine their main function. They initialize an SDL context as well as an audio subsystem. These variables represent SDL being initialized and allow you to use its functions. When they fall out of scope, they're automatically dropped. Then, they give a reasonable audio specification for what they want. They want 44,100 Hz, mono one-channel audio, and no specific buffer size. They use the audio subsystem that was previously initialized to open playback for a device with no specific name that ideally has the desired parameters, and then they handle it using a closure function that takes the actual specification as its only argument. They print out that argument, and then they return the square wave struct, which implements the audio callback trait. So this closure function must return something that implements the audio callback trait. The callback function will then be automatically called from the OS audio mixer in order to play back sound. Then, they simply resume the device in order to tell the OS to play sound. Then they wait 2 seconds as a simple way to specify how long to play a sound. Now, let's see how they get those samples. Here, you can see that their square wave struct keeps track of 3 values: the phase incrementation, the phase, and the volume. When implementing an audio callback, the square wave must specify what format it uses for samples, in this case a 32-bit float. Then it has to specify how it fills those samples, which you can see it does here in this loop. All it does is simply check its phase. If it's low, it returns a positive version of its own volume, otherwise a negative version. Then it increments the phase and does a modulus by 1.0 to make the wave loop. So let's translate this to our own program. First we tell Rust that we're using the SDL2 library. This pulls it into scope. In future revisions of Rust, that statement may not be necessary. I personally disagree with this because all of these items are only used one time, but I can understand why they would do it. The next thing that they do is create and describe their data structure. Now that's okay, but I would prefer to do that after main. So let's focus on main. Now I noticed they have a lot of calls to unwrap here. This is kind of an older Rust way of doing things, but in Rust 1.26 they added a feature that allows you to return a result from main, which is what I'm going to do. Then let's initialize SDL. We use the question mark operator here, which means that if initializing SDL fails, rather than having to unwrap in panic, the program simply exits with an error string. Now let's get the audio subsystem. Here I'm going to use a fancy little Rust feature to reduce the amount of code, and hopefully it shouldn't impact readability. So I'm going to split the function arguments among lines. So then what we're going to do is have a literal reference to a desired audio spec. Since I didn't import these with use, I have to do this up here. This is a closure that returns a finished audio device using a spec, like that. Alright, now let's just fill in the gaps. So we want one channel. If I were to substitute the sum1 for a none, it would pick the number of channels automatically. Then the sample rate, which I normally wouldn't really ask for anything specific, but I think some audio drivers will default to a very low sample rate for compatibility purposes, and we don't want that. Finally, a buffer length, which I don't really care about. Now in this spec, I need to return a struct, which I'm going to call mixer. And the mixer should need to know the sample rate, and let's say that we give it the pitch of one sine wave to make, like that. That's some wishful programming right there. I don't really know what I'm going to do, but I know that that's the information that the mixer's going to want. You just have to open playback on the device. And then I typed this line of code for waiting a duration. I don't care that it's really long because I know that I'm going to later substitute that for an application window or something. And finally, since our main returns a result, we need to return a result. You'll notice that the result return type is an empty tuple. That means that we have to put an empty tuple into this none, and no semicolon afterwards. And with that, our main function is fairly finished. Now all we have to do is implement our mixer. So just like there's square wave, we need to keep track of a phase and a phase incrementation value that's added to the phase every time we want to fill the buffer with a sample. And for this mixer, I fantasized that it would have a constructor that takes in a sample rate and a pitch. And whoops, it looks like the sample rate is actually some kind of integer type, but I'm not sure what type it is. So for now I'll leave it as a float 32, and when Rust's compiler complains about it, I'll fix it. So now I just have to specify a return value for this function. And we know that the phase starts at 0, but the phase incrementation we have to calculate. Let's take a peek at our formula from earlier. Well, I wouldn't exactly call it a formula, but you can sort of see what's going on. The way I like to think about it is, would the phase incrementation need to increase when a value increases or decrease? If it would need to increase, we should put the value in the numerator of this ratio that we're about to write. If the value is going to decrease, we should put it in the denominator of this ratio. So, let's think about it. First, the pitch of the wave. That's an easy one. Numerator. As the wave has a higher pitch, we would need to increase the phase at a faster rate. Remember that pitch is just the change in phase. We also know that 2 pi needs to be in here. No. Then we need to use 2 pi here. Then here's the denominator. We know that with a higher sample rate, the phase would be incremented more often. That means that when the sample rate increases, the phase incrementation needs to decrease. Let's implement an audio callback for it. The back in callback is not capitalized. So here's our associated type. And here's our function to fill the buffer. Callback. In here, we'll use a simple loop to fill the buffer. Oops, I need to specify a name here. Let's call it buffer. So we're going to do about the same thing that they did. And here's our volume. Then after getting a sample at the specified phase, all we have to do is increase the phase by the pre-calculated phase incrementation value. Alright, let's see if this program works. Cargo run. And then it will try to compile and run the program. The first thing that you'll notice is that it caught the type error, the number type error here. Unlike C or C++, I need to actually figure out what type I want here. And for whatever reason, the sample rate is a signed integer. I honestly couldn't tell you why, because that doesn't make very much sense. But I'll let it slide. We'll just cast the argument right here. Now it's telling me that I called a method called resume, but it's on a type that's an std result. This is a common thing that happens to people in Rust. And I need to not have a none here, because the result, it's actually OK or error. And finally, it's telling me that I set the phase to 0 when it should actually be 0.0. As you can hear, we just played a sine wave. This is the first large programming video that I've ever done, so let me know if there's anything that I should have said, or shouldn't have said, or should just clarify in general. I may re-record this video at some point when I'm more experienced. So if you like this video, be sure to like and subscribe, because I'm going to try to make more of these. Thank you, and goodbye.